This is the lecture for lesson 1. In this section, we will be looking at chapter 1:1, real numbers and algebra essentials. And for this lesson specifically, we are going to talk about natural numbers, whole numbers, integers, rational and irrational numbers, and then perform some calculations using order of operations and talk about some of the properties, such as inverse and identity properties of addition and multiplication, as well as commutative, associative, and distributive properties. As you can see here, we are going to work with all the real numbers. And all of our numbers are broken down into different types of numbers. The less specific you are, the closer you are to the top of this list. And the more specific, you go down here to the bottom. So all of our real numbers can be broken into 2 categories. They are either rational or irrational numbers. Rational numbers are going to be any number that we can put in a fraction form. So the number 5 can be put as a fraction over 1. The fraction 3/8. Any number that is a decimal that stops, so 0.13 is considered a rational number, or any number that has a repeating decimal, so 0.222, and if you put that little bar there, it means it's repeating. Those are all examples of rational numbers. Irrational numbers are going to be those numbers that do not repeat and cannot be written in a fraction form. For example, if you tried to do the square root of 2, that would be irrational. The example of the number pi. Pi is a non-repeating decimal, and you can kind of see that here. Non-terminating, non-repeating decimals. They can be positives or negatives. Really, where we're going to look today is not at those, but what's left over here. So once we have these rational numbers, how can I make them more specific? Well, we can then have what are called integers. So our integers cannot have a decimal part. So our rational numbers have 2 groups. The rational numbers can be positive or negative. They can be whole numbers, nice round numbers, or not. So inside of the rational numbers here, the only one up here that is an integer is the 5/1. So we cannot have any decimal parts when we get to integers. So we're getting more specific. But this could also be -8. As I move further down, I can create what are called whole numbers. So the whole numbers are only 0 and positives. So we're getting more specific. So we started with any fraction or decimal that terminates or repeats. Now we only want the positives. Or sorry, now we only want the round answers. And then here, now all we want is 0 and positives. So whole numbers are going to be 0, 1, 2, 3, 4, so on and so forth. Those integers are -2, -1, 0, 1, 2, 3. Those nice round numbers. Integer rationals then toss in the fractions and repeating decimals. And of course, if we get really, really specific here, our natural numbers are our counting numbers. Basically, the only difference between whole and natural numbers is we do not have 0. Now, I understand this may be a little confusing. You can use this chart while you are doing your homework. So have it available. Draw yourself a little chart if you want when you are going to do the homework. This first example wants us to use these numbers here to determine which are natural, whole, and integers. So they all have to be round numbers. So natural is 1, 2, 3, and up. Whole is 0, 1, 2, 3, and up. Integers can be negatives or positives. So -2, -1, 0, 1, 2, so on and so forth. So if we look at our numbers here, the first one is -7. The only one that can be negatives are integers. So -7 is an integer. Next one, we have a decimal. Well, none of these can be decimals, so this cannot go for any of them. Next is 0. Well, 0 is in the whole numbers and it is an integer. So I'm going to put it with whole numbers and integers. Next one is a trick one. The square root of 49 is equal to +7. So the square root of 49 is +7, which means it is actually all of these. So square root of 49 can be listed in any one of these. And then lastly, the square root of 50. If I were to type that in a calculator, that's going to give me a long, crazy decimal. It's not going to go for any of these. Next question says, give an example of a number that is a whole number, natural number, and an integer. Well, we got one, right? Up here, the square root of 49 was 7. Any positive round number you give me is going to fit in both natural, whole, and integers. So 100, 25, any number that is a round positive number is all three. The next example wants us to distinguish between rational and irrational numbers. Now, these are complete opposites. So if you are rational, you cannot be irrational. They are complete opposites of each other. So rational can be written as a fraction, a repeating or terminating decimal. And these are the ones that do not repeat, do not stop. So do not terminate or repeat. -5 is a nice round number. It is a rational number. Next number, -0.3 with a bar above it means it's repeating. That is a rational number. 0 is a rational number. The square root of 2 is not a rational number. If I type that in my calculator, my decimal runs the whole screen. It does not repeat, and it actually does not end. It continues past what my calculator shows me. But the square root of 4, well, if I do that, I get 2. The square root of 4 is 2, so that comes out to a nice round answer. That is going to be rational. So any non-perfect square under the square root is going to be irrational here. So maybe we should review our perfect squares. Our perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. So 2 squared, 3 squared, 4 squared, so on and so forth. Just remember these are opposites. So if you have a rational, it is on the rational side. If you cannot get a rational, then it is irrational. The next thing we're going to do is review the order of operations. Now, you may have remembered this phrase, please excuse my dear Aunt Sally. Before we do this, I want to clarify some things. The reason we have an order of operations is so that everyone, when doing the same mathematical problem, will get the same correct answer. Now, if any of you are on social media, I'm sure you've seen those math problems where people argue back and forth. No, it's this answer. No, it's that answer. And the reason it fails, or some people get it wrong, is because they missed a very important part of this order of operations that I'm going to explain here in just a second. First is always parentheses. Always. If there are any parentheses and there are operations you can do inside those parentheses, you must do that first. Next is exponents. Third is multiplication and division in the order they occur from left to right. And this is where people get it mixed up. Some people will go through and say, no, I must do all the multiplication first, and then I do all the division. And that is not correct. It is multiplication and division in order from left to right. And the same holds for addition and subtraction. You do not do all of the addition first. Okay? These are grouped together. M and D are grouped together. They have the same rank, so you must do them in order that they occur in the problem. Same with addition and subtraction. They have the same rank, so they must be done in order from left to right. Let's do some order of operations. The first problem is 10 squared minus 100 divided by 5 squared times 2 minus 3. This problem has no parentheses, so the first thing we're going to look for then is our exponents. I have 10 squared and I have 5 squared, so I'm going to do both of those. 10 squared means 10 times 10, which is 100. I'm going to carry over the minus 100, divide by 5 squared is 25. Then I have times 2 minus 3. So now I am to the point where it is multiplication and division from left to right. So the first thing I see here is this division. 100 divided by 25 is 4. I'm going to carry everything else down. So the 100, the minus, the times 2, and the minus 3. Still working multiplication and division. 4 times 2, so 100 minus 4 times 2 is 8, and then minus 3. Now I'm going to do addition and subtraction, of which there's only subtraction from left to right. So 100 minus 8 is 92, and if I subtract 3 more from that, I'm going to get 89 as my final answer. In B, we have 8 minus 3 times the quantity, negative 2 times the quantity 5 minus 7, minus 5 times the quantity 4 minus 2. So in this problem, we have brackets and inner parentheses. So the first thing I'm going to do is these inner parentheses. I'm going to carry everything else. 8 minus 3 minus 2. What do we have? 5 minus 7 is negative 2. So inside of that parentheses, I'm going to put negative 2. I've got minus 5, open parentheses. 4 minus 2 is 2. Close and then close bracket. So we still need to work inside of these brackets now. And when you see two numbers written right next to each other without an operation symbol, that means to multiply. So that means I want to multiply this 2 together and multiply these 2 together. So 8 minus 3 times the quantity. Well, negative 2 times negative 2 is 4. I'm going to carry down my minus sign, and 5 times 2 is 10. Now, I'm still not done with these brackets. These brackets are the same as parentheses, so I'm going to keep working here with that. 4 minus 10 is negative 6. So I now have 8 minus 3 times the quantity negative 6. So now I'm going to do my multiplication piece here. So with this multiplication piece, I have negative 3 times negative 6, which is going to give me positive 18. So this becomes 8 plus 18 for a final answer of 26. And then C, we have a fraction. So before we do anything, we have to start with the parentheses. So in the parentheses on bottom, I have a subtraction and a multiply. So I'm going to do the multiplication first. So 10 divided by 2 plus 3 times 4 is going to be over 12 minus, well, 3 times 2 is 6. And then I'm going to do that and square it. So keep working here. I'm still working on the bottom. 10 minus 6 in parentheses is 6, which I then need to square. So now I'm going to do that exponent part. Still not touching the top, doing one piece at a time. 6 squared is 36. So now I can do the top. So I'm going to do multiplication and division in the order they occur from left to right. So division is first. 10 divided by 2 is 5. 5 plus 3 times 4. So the operations I have left are addition and multiplication. Multiplication comes before addition. So I'm going to do that piece first. So 5 plus 3 times 4 is 12, all over 36. And lastly, 5 plus 12 is 7 over 36. Fix my typo there. Okay, so we're going to start with some properties here. I'm going to work with addition and then work with multiplication. In each operation here for addition and multiplication, we have an identity property and an inverse property. The identity property of addition is asking us, what is the number that if I add it to any number, I don't change my number? And you can see here that any number, if I add 0, my answer doesn't change. So the additive identity is 0. So additive identity is 0. If I take 1 plus 0, I stay 1. Any number plus 0 is that same number. Using the identity, we can then talk about the inverse property. So the inverse property is what number do you have to add to a number so that you get back to 0, get back to that identity? And that's going to be its opposite. So if I have 5, I would have to add -5 to get back to 0. So those are two properties with addition here. So the identity is when I add 0. The inverse is when I add the opposite to get back to 0. Now, we also have rules within multiplication. So I can take a number and multiply it by a number such that it does not change my number. And that is with the number 1. If I take 7 times 1, the answer does not change. So the multiplicative, it's a long word, multiplicative inverse is identity is 1. Which means that there is a way to take a number and multiply it by a number so that you get the identity of 1. And that's what's explained down here. And that inverse is the reciprocal. So any number that I have, 7, let's say, its reciprocal 1/7, if I multiply, will give me the identity. 2/3 times its reciprocal 3/2 will give me 1, because 2 times 3 is 6, 3 times 2 is 6, and 6 over 6 is 1. So these examples just want you to be able to look at the problem and say, what identity was being used here? So the first thing I know is if I see an addition sign, it's addition something. So A and B are both of our addition, addition, addition. And one of them has to be the identity, one of them has to be the inverse. And if we look back on the previous slide, this top one is our identity, and the second one is the inverse. For C and D, there's a multiplication symbol, so I know we're doing multiplication. The first one is the identity, and the second one is the inverse. So just, can you look at the problem and tell me which identity it is? Some more properties that we use are called commutative property of addition And basically what it's saying is if I'm adding three numbers together, it does not matter which order I add them in. So if I have 5 plus 3 plus 7, I could do 5 plus 3 first and get 8, and then add the 7, and that'll give me 15. That is the same result as if I did 3 plus 7 first and got 10, added 5, is still going to give me that 15. So as long as it's all addition, it does not matter which order I add them in. Let me correct these symbols here. These should be multiplication symbols. I apologize. The associative property of multiplication tells us that it does not matter how we group numbers when multiplying. So just like addition, if we are only multiplying, say three numbers together, it does not matter which order I do them in. So 3 times 2 times 5. If I do 3 times 2 first and get 6, 6 times 5 is 30. That is going to give me the same answer as if I do 2 times 5 first and get 10, and then times that by 3, I do still get 30. The last rule here is the distributive property that says if I have a number outside of two terms, I can distribute that term by multiplication to each of the other two terms. So let me just show you quick. If I have 3 times 5 plus 2, I can do 3 times 5 plus 3 times 2. So 3 times 5 is 15. 3 times 2 is 6. Add those together, I get 21. I'm going to show you that's the same answer if I follow my order of operations. So order of operations tells me I should add those together first. 5 plus 2 is 7. And then 3 times 7 is 21. So you'll see here that, again, they are the same answer. And there's the property. All right, so for 6, they just want us to label which property it is that we were using. So we have an 11 times a quantity, and that becomes 11 times 7 plus 11 times 4. So we did the distributive property. Next one is 6 times 2 times 3 is equal to 6 times 3 times 2. So they change the order of the multiplication, and that is associative property. And then just some simplifying here. 6 plus negative 4 gives you a 2. 6 plus 2 plus 7, so that would be 6 plus 9, or 15. And this one here, you have your choice. You can distribute, or you can combine the insides first. I combined first. 3 plus 11 is 14, and 8 times 14 is negative 112. The next group of problems is going to work on evaluating and simplifying algebraic expressions with one variable, two variables, talking about constants, variables, being able to use a formula, and simplifying. The first thing we're going to do is evaluate an algebraic expression with a single variable. So our expression says 3x minus 2 is the value of our function. So what we want to do is we want to find the value at all of these different x's. So all that means is plug in the given x where you see x. So 3 times 1 minus 2 is what we want to find. Well, 3 times 1 is 3, and minus 2 gives me a value of 1. Next one wants us to evaluate at x equals a third. So 3 times 1/3, and then we want to subtract 2. Well, 3 times 1/3, that's our multiplicative inverse, and we're going to get 1. 1 minus 2 is going to give me negative 1. Next, we want to plug in negative 1. So 3 times negative 1, and then subtract 2. Well, 3 times negative 1 is negative 3, minus 2 is going to give me negative Next, plugging in 3. 3 times 3 minus 2. 3 times 3 is 9. 9 minus 2 is 7. And our last one here, plugging in -2. 3 times -2 minus 2. Well, 3 times -2 is -6. And if I subtract 2 from -6, I go to -8. We're going to keep evaluating expressions, but now we have more than one variable, and it's going to tell us which each of those variables represents. For number 6, we have 2m squared plus 6n plus 3, and we want to use m is 2 and n is 6. So 2 times 2 squared plus 6 times 6 plus 3. Exponents are going to be first. So 2 squared is 4. So I have 2 times 4 plus 6 times 6 plus 3. Now I can do each of those multiplications here. 2 times 4 is 8. 6 times 6 is 36. And now we can just do our addition. 8 plus 36 plus 3 is going to leave us with 47. Seven wants us to take the square root of 9a minus 9b, using a is 10 and b is 1. So 9 times 10 minus 9 times 1 is where we want to go. So starting with the multiplication, 9 times 10 is 90. 9 times 1 is 9. 90 minus 9 is 81. And I can square root 81. I get the answer, 9. And then for question 8, we have -2 times the quantity x minus 1 squared plus y minus 2. We're going to let x be 2 and y be 9. So -2, 2 minus 1 squared plus 9 minus 2. All right, so I'm going to work my parentheses first. 2 minus 1 is 1. Carry everything else down. 1 squared means to take 1 times itself. Well, 1 times 1 is 1. Carry everything else down. So -2 times 1 plus 9 minus 2. So multiplication comes next. -2 times 1 is -2. I'm going to add 9 minus 2. -2 plus 9 is 7. And then 7 minus 2 is 5. The next thing they want us to do is, given a string of terms, can you pick out what the constants, variables, and I'm also going to add this term in here, coefficients, because I believe when I was looking at the homework, it does actually ask you about a coefficient as well. So constants are numbers by themselves. Variables are going to be the letters. And the coefficients are numbers attached to letters. So when I look at number 9 here and I have 3c minus 4, well, it's really easy to pick out the variable. That's the easiest one to pick out. So the variable here is c. But what is 3 and what is that -4? Well, 3 is attached to the c, so it is called a coefficient. So the coefficient is 3. And this number by itself, always include the sign in front of it, is your constant. Next, so I'm always going to start with my variables. I have 2 pi r. R is the variable. 2 and pi are both numbers that are attached to the letter r. So they are coefficients. The coefficient is 2 pi because this is the number portion attached to r. Remember that pi is roughly 3.14. All right, last one here, we have 4t squared plus 3u minus 7v. So all of our variables here are t, u, and v. Those are our letters. And our coefficients are going to be the numbers in front of the variables. So 4, 3, and -7. There are no constants. There are no numbers by themselves. Now, one thing I want to discuss really quick, it's not in an example here, is if I have 4x plus y, my variables are x and y. But what are my coefficients? Well, in front of the x is a 4. What's in front of this y here? It's an invisible 1. So this y has a coefficient, and it is a 1. So just wanted to point that out to you. One reason we work with these expressions and talk about constants and variables and things like that is to be able to use things like formulas. Formulas are filled with variables that we need to be able to fill in to be able to solve a problem. So for 12, it says the area of a trapezoid is given by the formula area equals 1/2 height times the quantity of the base 1 plus base 2. So if the height of the trapezoid is 10 centimeters and the bases are 12 and 15 centimeters, can you find the area of the trapezoid? Well, sure. All I have to do is plug in those pieces. Area is 1/2, the height is 10, and then the two bases are 12 and 15. So I'm going to work with the innermost parentheses here on the right. 12 plus 15 is going to give me 27. And now I have three pieces of multiplication that I'm going to do in order here. So 1/2 times 10 is 5. And I'm going to take that result times 27. 5 times 27 is 135. Now, one thing you're going to need to know is anytime you're talking about area, your units are going to be squared. So centimeters squared. So area is always squared. And in 13, we're going to get to volume. Well, volume is always units cubed. So area is units squared, volume is units cubed. So it says here the volume of a square pyramid is given by the formula volume equals 1/3 the area of the base times height. If the area of the base, the capital B, is 100 centimeters squared, so we can fill that in, 1/3 times 100 times the height. Well, if the height of the pyramid is 12, can we do that? All right, so what I'm going to do here is, for me, I know I can't do 100 divided by 3. And because this is all multiplication, I can rearrange the order here. So I'm going to change it to 1/3 times 12 times 100. Because I know I can do 1/3 times 12, or 12 divided by 3 gives me 4. And then take that result times by 100 and get 400. That was using the associative property of multiplication. And our final answer is going to be centimeters cubed. The last thing we're going to do here is just combine some like terms and use some of those properties like distributing. So in order for two terms to be like terms, the variables and their powers must be the same. So let's start with this first guy here, number 14. I have a -2 that I'm going to need to distribute into the parentheses. And then I have a 6 here that I'm going to distribute into these parentheses. So -2 times x is going to give me -2x. -2 times -2 is going to give me +4. Then if I do 6 times 2, that gives me 12. And 6 times x is 6x. Now what I'm going to do is I'm going to look for the terms that look the same. So -2x and +6x can combine. If I have 6 x's and I take away 2 of them, I'm left with 4 x's. I then have 4 that I want to add 12 to, and I'm going to get 16. You will not change any of the powers. You don't add powers. It's 4x When you combine 6 x's and you take away 2 of them, you still have x's. All right, 15. I'm going to start with that distribute here. I need to distribute a -1. It is invisible there, but I need to distribute it. So 3z squared plus 2z, and I'm going to distribute that in. -1z squared, -1 times 1 is -1, and then minus 7z. So now I'm going to look again for terms that are matching. So I have 3z squared and -1z squared. So if I have 3 and I take away 1, that leaves me with 2z squareds. Next, I have positive 2z and a -7z. So the variables and powers match. 2 minus 7 is -5z. And then on the end, doesn't have anything to go with it, is that -1. And the last one here, 3a squared plus b squared plus 7a squared minus 5b squared plus 2a squared. So let's look at the a squareds. I've got 3a squared plus 7a squared plus 2a squared. Well, 3 plus 7 is 10, plus 2 more is 12a squareds. And then let's look at the b's. I have 1b squared, and I want to subtract 5b squareds. 1 minus 5 is -4b squareds. This is the end of lesson 1, so you should be able to work on your homework now.